The Nanyang Technological Institute can justifiably feel proud of its new complex, and in particular its spacious and modern laboratories, which house some of the most sophisticated and up-to-date automated equipment. However, it still recognizes the vital role that basic hands-on experience plays in the practical training of young undergraduate civil engineers. Thus, it requires all second-year students to undertake an in-house practical training course relating to the planning, design and construction of a full-scale structure. The importance and relevance of such a program of intensive training are summarized by Professor Chen Cha-ning, Dean of the School of Civil and Structural Engineering.
In 1981, NTI was established as a university of the industry, and to this end, many of the courses have been structured to incorporate aspects of practical training. Projects such as the in-house practical training, or IHPT, expose students to the type of challenge awaiting them in the construction industry upon completion of their formal academic studies. Previous year's projects have incorporated structures which have all become integral features of the NTI campus. In 1983, the first IHPT project involved the construction of 5 reinforced concrete structures having hyperbolic paraboloid roofs. These structures now form part of the CSE construction laboratories. In 1984 and 1985, a spectator gallery and a multi-purpose games arena were built to add to NTI's sports facilities. In 1986, the school embarked upon the construction of the first 2 units of the proposed CSE experiment station, incorporating reinforced concrete shell roofs.
The planning of the project involves the joint collaborative efforts of staff members from several different disciplines over a period of 9 months.
No objection to improving, but not to keep on trying to improve it and come up with nothing. But there must be at least some scheme ready for the students to work on.
Because this
Alternative designs are first formulated and assessed, structural drawings and contract documents prepared, and models of important components of the final structure tested to investigate the adequacy of the selected design. The 1987 project requires the construction of 2 further units of the CSE experiment station, but differs from its predecessor in several distinct ways. The key differences and the extent of model testing and calibration are explained by Dr. Chan Kin Sen.
In the 1986 IHPT project, the roofs were cast as monolithic structures near ground level and hydraulically jacked onto their final positions. In this year's project, the segmental precast construction has been adopted. Each roof is cast near ground level in 4 quadrants, which are stiffened by the edge beams. The spine, tie beams, and columns, which support the roof, are cast in situ. The quadrants are temporarily tied and lifted onto the structure, and the entire assembly is ground to form a rigid structure. Long before actual construction, in a trial test, a 1/10 scale model of the spine beam supporting structure was constructed, instrumented, and tested to more than twice the expected working load of the prototype. This test proved to be successful.
It's basically pass the information to someone who can build it.
During the first few weeks of the training program, students receive supplementary lectures and tutorials on bar bending, formwork design, and project and financial management. As part of the total instructional package of the IHPT training, students are given exposure to computer-aided design and drafting applications. Students are also required to attend a geotechnical workshop and undertake related exercises, which in the case of this year involved soil exploration, including boring and sampling and in situ testing. To resemble a real-life situation, students are allocated to 4 construction companies. Each student, within the construction period, will be a member of either the management or office staff or help on the site, with the roles being rotated weekly. Every Saturday morning, a progress report is presented by the management group to the remaining team members. It reviews the difficulties experienced during the week, progress made, and discusses work to be encountered during the following week. At the same time, reference is made to important key issues such as quality control, safety enforcement, and the general financial position of each company. Both the individual performance of students and the progress of the company as a whole are monitored by members of the academic staff, who are designated as staff in charge. In addition to administrative duties, it is their task to act as consultants and technical advisors.
We have to be committed. It is as a house, as a body, every part is in the same body. We can.
Good afternoon. My name is Edwin Tan, and I'm with the Dynamic Builders Private Limited. My job today is to give you a brief commentary on the construction of a shell roof. However, before doing so, it is worth recapping on the main features of the construction program so far. Before we commenced our site work, board piles were installed, and our first task was to verify the position of the center line of each pile. The formwork for the reinforced concrete shell roofs had also been erected prior to our arrival on site, in order that we could complete the entire construction program within the very tight time schedule. The first major item to be faced by all the teams was the construction of the reinforced concrete columns. This involved the mechanical sawing of timber for the formwork and fabrication of the reinforcement, prior to the actual concreting taking place. The concrete for the columns was placed with the aid of a skip, and the freshly placed concrete compacted with poker vibrators to ensure that it contained no air voids which may have reduced its strength. It was also necessary to test the quality and strength of the concrete, and so whilst it was being placed, slump tests were performed and samples of concrete taken for subsequent crushing tests. This procedure was repeated for all further deliveries of concrete. Whilst this was underway, other members of the construction companies erected scaffolding and prepared the reinforcement and formwork for the tie beams. Each reinforcement bar had to be bent and cut to the precise length as indicated on the working drawing. As a considerable number of workers were available on the site at any time, it was possible to undertake several different tasks. So, when the tie beams and columns were well advanced, some members of each team were delegated to work on top of the roof formwork in order to place the mesh in position for the roof slab. All concrete is ready mixed and delivered to us by trucks. To ensure that an adequate amount of concrete could be ordered to make the delivery worthwhile, each construction team had to ensure that it maintained good progress and kept up with schedule.
It is now the middle of the 4th week of the in-house practical training program. Over the past few weeks, my fellow teammates have been busy on the construction of columns and tie beams while we have been working on the actual shell roof structure. Each team is responsible for the construction of 2 quadrants for each shell roof. But as there's only one timber formwork mold available for each team, the construction has to be carried out over a 2-cycle process. We are approaching the end of the first cycle as we are ready to begin concreting. The correctness of the reinforcements in terms of size and placement has been checked and verified by the staff in charge and the Construction Engineering Committee. As a large quantity of concrete is required, ready-mixed concrete is being used. The concrete is now being placed over the bottom half of the shell roof. After the concrete has been placed, it is then compacted by means of poker vibrators. We are gradually building up the concrete from the bottom of the roof to the top. This sequence enables the compacted concrete to support the fresh concrete over the steep part of the roof structure.
Hello, my name is Jayanti and I'm with the Century Construction Private Limited. We are more than halfway through our in-house practical training, this being the 7th week of our 10-week program.
During the last 3 weeks, significant progress has been made. After the position of the reinforcement and the adequacy of the formwork had been checked by the Construction Engineering Committee, the tie beams were concreted. After concreting the roof and allowing sufficient time for curing, the quadrants were lifted clear of the formwork and temporarily stored at ground level. A lifting frame comprising of steel beams was used to raise the roof slabs with the aid of lifting hooks which had been cast into place at the corners of each slab. To stiffen the structure during lifting, steel ties were secured to the underside of each quadrant, spanning between adjacent corners. The timber formwork molds were then available for the construction of the remaining quadrants, and so the cycle of positioning the reinforcement, placing and curing the concrete, and lifting the roof shells was repeated.
So far, we have learned a great deal about civil engineering construction as the whole spectrum from top management and financial control right down to site safety and construction skills have been covered. As we built up the thin shell roof structure, we got a lot of fulfillment in seeing the structure slowly take shape. For the structure to take shape, we first started out with the setting up, followed by the cutting and fixing of the formwork, then the bending and fixing of reinforcement bars, and finally the placing and curing of concrete. Indeed, today we are just about to do the last leg of our concreting, that of the spine beams. The formwork and reinforcement of the spine beams was very challenging, as these are not just simple straight horizontal bars, but instead are curved structures forming the diagonals of the roof structure. Our company constructed this particular spine beam. As each roof structure consists of 2 spine beams which intersect each other in the center of the structure, we had to coordinate our work with that of our neighboring construction company, and hence we were able to appreciate the importance of coordination and cooperation in a construction project.
The construction method adopted for this year's IHPT project dictated that the roof quadrants were precast and then lifted onto the spine beams and tie beams. Additional features had to be incorporated into the roof quadrants in order to ensure their structural rigidity, as now described by Dr. Pan So Chien.
First, 3 temporary steel ties like this one has been provided for each quadrant. Because of the shape of the structure, it has a tendency to flatten out. These steel ties are here to resist the flattening action. Secondly, the structure doesn't have a uniform curvature. As you can see, in the back of the structure, the curvature is relatively flat. In order to take the design load over that area, we need to provide edge beams such as this one, and each quadrant has been provided with 2 edge beams.
And so to the high points of the construction program, the lifting and placing of the quadrants. In order to minimize the transfer of unsymmetrical loading onto the spine beams, the placing of the quadrants has to be in a particular sequence. After the first quadrant has been placed, the second is placed diametrically opposite. Finally, the third and the last quadrants are lifted and placed in position. The final act, which ensures the structural integrity of the whole roof, is the grouting of the joints between the edge beams and spine beams. The completed structures symbolize the achievements of the students over the 10-week training program, and they will remain as permanent reminders of their hard work and dedication. During the course of the in-house project, each company is invited to tender for the construction of a leisure-cum-shopping centre on a turnkey basis. The exercise, although only a simulation, helps students to develop an appreciation of the fundamental concepts associated with the planning, design and construction of an engineering project.
Our company would like to take this opportunity to thank you all for inviting us here.
The end of the training program is marked by an oral presentation from all 4 companies. They compete against each other in a bid to secure the lucrative contract, and in doing so are able to display their technical expertise, presentation skills, and recently acquired construction experience.
The concentration of population and activities